Alright, Dylan here for my culminating project. As you can see, we have Roadrunner going back on a slingshot. He's going to generate elastic potential energy for himself the more he draws back on the string. You can see it's getting tighter. He's eventually going to reach a tree or something, pull himself back. He has a lot of potential energy here. He's about to turn it all into KE. He wants to kill Roadrunner, I think, so he's going to shoot himself off at a great rate of knots, as you can see now. And you can see he goes through multiple objects. Numerous forces act on him without affecting him. He apparently is invulnerable to rocks and stuff. Roadrunner breaks his ankles right here, as you can see. Doesn't filthy like Megamind in this clip, but so several, or at least two here, rules of physics are broken here, as you can see. If we go back to this clip of him hitting the sign, Roadrunner clearly hits the sign while in projectile motion, yet is not affected whatsoever. He doesn't slow down, he doesn't stop, he just goes through it, kind of. He should be greatly slowed down here, maybe even stop depending on the object he hits, but he continues unaffected, which breaks the law that Newton made, which states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force, which clearly in the clips, Wile E. Coyote is acted upon by numerous forces, those being obstacles he hits and just goes through like he's a tank or something. So I came up with the cartoon physics law that outside forces acting on an object will have zero impact on its velocity or direction, meaning they won't affect it at all, I guess. But yeah, moving on to Roadrunner himself. Something you might notice is his braking distance in this clip. So I did a little research. I just tried to find out roughly in this cartoon world how fast he actually goes. He apparently can cruise, just like kind of jog for him, around, 150 kilometers per hour. So I just said for this observation, I'm going to assume he's going 200 kilometers per hour. You can see his legs are spinning. We can't even see them. They're going as fast as a propeller. So yeah, as you notice, he's in this scenario going 200 kilometers per hour, and he appears to be able to have a braking distance of not a lot. I timed it. It was 0.67 seconds it took him to brake after running at that speed. And I did some calculations. I did a calculation for stopping distance, d equals v squared over 2 coefficient of friction times gravity. And the coefficient of friction, I used pavement because he's apparently running on pavement. I used rubber to pavement because I'm just going to assume his feet are made of rubber or something like that. I don't know. But logically, in a real-world scenario, he should have a stopping distance 107 meters after running at that lightning speed. But with the calculations I did, I calculated the acceleration of him stopping, which was 82.8 meters per second. And then I also calculated the distance overall with the time and his initial speed. He stopped within 18.6 meters. It looks even less like that in the clip, but I came to the conclusion that in the cartoon world, or at least Looney Tunes for that matter, braking distance is roughly 5 meters less than the real world when Roadrunner is the one running. Alright, quickly moving on to our last topic, we have a very typical one. The law of gravity is broken here by Tom, from Tom and Jerry. He is slingshotted up by Jerry, and as you can see, he goes flying. Apparently he even reaches a greater airspeed than an aircraft, a bird, and the gravity does not work until he looks down. He continues in a straight path, completely unaffected until he looks directly down. Obviously projectile motion, it should be an arc, sort of like a semicircle, but he goes in a straight line upon being slingshotted, and upon looking down, 90-degree vertical drop like the Yukon Striker. And so based on that, I've concluded that in the cartoon world, gravity does not work until you look down. And to quickly wrap things up, another thing we can look at is how characters don't die. Obviously, Tom just fell from, say, 8,000, 12,000, who knows how high up the altitude, but a fall like that should have reset him to default settings or something, put him on a respawn screen, but he gets up just fine. And now I have run out of time. I'm going to be a tiny bit over 5 minutes, but I hope you guys enjoyed. I don't know, Samurai slice that like button, but thanks.
Dylan.